Hello, and welcome to our continuing study of infinite series. I looked at the integral test in the last section, and here I just want to work a couple of examples of well, of convergence in general. And the first one, I'll use the integral test. And then the second one, we'll do something called the comparison test. But I want to look at this series in particular. It's the sum little n equals 1 to infinity of 1 over n times the square root of n. And the question is, does that converge? Now, one of the things that is important to make sure that you understand is that we're not, when we're asking if this series converges, I'm not asking if the terms get smaller and smaller and smaller. Obviously they do in this case. All right, so I know that as n goes to infinity, that just this thing, as that denominator gets bigger, just that thing will approach 0. But the difference is what we're doing here is we're adding an infinite number of those things together. So and what the question is, and what the question is if we add an infinite number of those things together, are we going to get something that blows up or that approaches some value? So that's what we mean by convergence. So we're going to do the integral test for that. We're going to compare to the integral from 1 to infinity of 1 over x to the 3/2 dx. All right, so this is still a series with positive terms, and we're going to compare it to 1 over x to the 3/2. Note that n times the square root of n is n to the 3/2. All right, so we want to take that integral, and that is what? The limit as b goes to infinity. Integral from 1 to b. Oops. Integral from 1 to b of 1 over x to the 3/2 dx. And so what is that? That is equals the limit as b goes to infinity of the quantity. So it's x to the 3/2, so it's going to be negative 2 times x to the negative 1/2. Yeah. And then evaluated 1 to b. And that is negative 2 over square root of b minus, or plus now, 2 over 1. And so this is, and that's the limit. Put that in there. Of that, and so this is 2. And that means, since the integral converges or is finite, that means that the series converges. We don't know where, but there it is. All right, so the second one, let me move this page up. The second one is going to be this one. So I'll write out the series. So does the series 5 plus 2/3 plus 1. I'm just making up a couple numbers here. Plus 1/7 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial plus dot 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 converge. All right. Well, the beginning 4 terms are nothing. I mean, they're something, but they're not part of any pattern. They're just sort of tagged on. So really what the question is does this converge? Okay. So really, does this converge? Because I know that the first 4 terms converge. They converge on whatever that sum is. 5 plus 2/3 plus 1 plus 1/7. So this is what we want to know. So I want to compare this to compare the 1 over k factorial, or n factorial part to 1 over k squared, or n factorial, n squared. So, yeah, I'll write out the terms again. Well, I'll just write out the whole thing. 5 plus 2/3 plus 1 plus 1/7 plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial. All right. So if we have the terms, the 1 over n squared terms, if n is equal to 1, all right, we'll have that. I'm going to write these in blue. So 1 over n squared. We could just sort of tag this in here. This would be 1 squared. This could be 1/4 plus what, 1/9 plus 1 over 16 plus 1 over 25. And we know, maybe even from the last example, that the 1 over n squared series, that's going to converge. And if we compare these terms together, that is to say this, each of these consecutive terms, this is what, 1 over 6 compared to 1 over 9. Okay, so that one's a little bit larger, but that's it, because this is 1 over 16. Those two are equal. And for this one, we get 1 over 5 factorial is what, 125 or something? It's and actually that's not, these aren't equal. This is 4 times 3 is 12. So this number here, each of these successive numbers is going to be less than the one I can put next to it. So the 1 over 4 factorial, since that 4 factorial is larger than 16, that's going to be a smaller number. 1 over 5 factorial is a smaller number than 1 over 25. And I can keep going on like that forever. So the point is for that since we know 1 over n squared converges, we know that this one converges. So write that, since 1 over n squared converges, so does our series. All right, so I just wanted to work on those 2 examples. Thanks for watching.